Good afternoon and welcome. Today we're going to be starting our first day of section 8.3. We're going to be covering this section for 2 days, so both today and tomorrow we'll be talking about 8.3. In this section, what we're going to be discussing is a quadratic that now has a b times x term in the middle. Previously, our quadratics had the ax squared, and then we added on the plus c, or that constant term, and now we're going to include that plus bx term in the middle. The first thing I want to discuss is the opening of the graph. The graph is going to open upwards when, if we're looking at this standard form of a quadratic, the a, or that leading coefficient that I've mentioned previously, is a positive number. When your a is positive, your parabola will be facing upwards. If that a value is negative, your graph is going to open downwards. So when a is less than 0, your graph is going to open downwards. Next, the y-intercept. If we go through and find the y-intercept of this equation, what we would be doing is simply putting a 0 in everywhere there's an x. If I put a 0 in for each of these x's, then I would just have 0 plus c. So your y-intercept is simply that c value, or the constant term that's added on to the end. So if we look at the graph in the picture, we can see that this y-axis is intercepted by our parabola at the point 0 for x and c for y. The x-coordinate of our vertex can be found using this formula, negative b over 2 times a. And we get those values of b and a from the standard form of our quadratic. So b is the coefficient on your x term, while a is that leading coefficient, or the coefficient on the x squared term. If that's the x-coordinate of our vertex, it's also our axis of symmetry. So our vertex has the coordinates x, y. The x-coordinate can be found by simply plugging in values for negative b over 2 times a. And we can use that x-coordinate to then find out what the y-coordinate of our vertex is. So we would plug those values in to find y. But our axis of symmetry we've talked about is the equation where simply x equals whatever that x value is. But the x value is negative b over 2a. So our axis of symmetry is the equation where x equals negative b over 2 times a. That's going to give us that vertical line that kind of splits your parabola right down the middle. In example 1, we're going to find the axis of symmetry and the vertex of the graph of the following function. The first thing we're going to look for is our x value of our vertex. Our vertex has an x value of negative b over 2 times a. Once we find the x value, all we're going to do is take that x value and plug it into our function, and that will give us our y value. So how we can notate the y value is f of whatever that x value was when we plugged in values for b and a into our negative b over 2 times a formula. So the x value of my vertex is negative b over 2 times a. In this function, I've got an a value of 2. B is the coefficient on x, so b is going to be 8. And c is going to be that constant term added on to the end, which in this case is a negative 1. So I'm going to go ahead and plug these values in. X is equal to negative b, and b is a positive 8, over 2 times a, and a is a positive 2. So x is equal to negative 8 over 4, and when I divide, I find that x is equal to negative 2. So this is the x value of my vertex. So the first part of my ordered pair for my vertex is negative 2, comma, something. I need to find out what that y value is, so all I'm going to do is plug it in. F of negative 2. I take the x value, plug it in to find the y value. That's what this notation is saying, it's just in terms of the b and the a. So now once I found that negative b over 2a, I plug it in for my x values to find f of negative 2 is 2 times negative 2 squared plus 8 times negative 2 minus 1. Remember to do your exponents first, please, so this becomes a positive 4. So I've got 2 times positive 4 plus 8 times negative 2 minus 1. 2 times 4 is 8. 8 times negative 2 is a negative 16, or minus 16, minus 1. This gives me negative 8 minus 1, which is a negative 9. So I plugged in my x value of 2 and got a y value of 9, negative 9. So my vertex is the coordinate negative 2, negative 9. If I'm trying to find my axis of symmetry then, we should know it's the equation where x equals the x value of the vertex. So it's simply x equals negative 2. These are the two things they asked us to find, so once we have found them, we are done. I'd like for you to go ahead and take a second to try the next 3 on the screen. I'm going to go ahead and start working through them as you guys are still working. So when I plug this in, I got an x value of positive 1/3 and a y value of negative 1/3. So my vertex has the coordinates 1/3 for x and negative 1/3 for y. One thing that you need to be careful of in this first question is that since your b value is negative, up here I had a b value of negative 2. When I plug that into my formula is negative b. So I have negative from my formula and then my b value of negative 2, which allows this to become positive 2/6 or positive 2/3. Since I found my vertex, I can find my axis of symmetry, which ends up being x equals simply 1/3. So my vertex and my axis of symmetry are as follows, and you are done with number 1. If you need more time on number 2 and 3, go ahead and take a second to pause the video and take as much time as you need. In just a moment, I'm going to go ahead and put up the answers for numbers 2 and 3. For number 2, I got a vertex of -3, -4, and an axis of symmetry of -3. For number 3, I got a vertex of 7 and 41/2, or 20.5, and an axis of symmetry where x equals +7. Here we're going to go ahead and describe the domain and the range of this graph. So the one thing I want to touch on here is that when you have a parabola, here's a quick little graph, it looks something like this. Our x values, or our domain, is unrestricted. Even though it goes to the left slowly, it goes to the left forever. Similarly, even though it goes to the right slowly, it goes to the right forever. So the domain for parabolas is always going to be all real numbers. Now our range is a little bit different. If our parabola faces upward, the range always starts at the vertex and goes up. Now if our parabola faces downward, like this blue one that I'm drawing, then our range values for y start at the vertex and go down. So all we're really looking for here is what is the y value of the vertex, and then we're asking, does our graph go up, so our y values are bigger than the vertex, or does it go down, so our y values are smaller than the vertex? So my first step here is to find the vertex. -b over 2 times a, so -6 over 2 times 3, which gives me +6 over 6, which just reduces down to 1. When I plug that back in, f of 1 is going to give me a +2. So my vertex for this question is 1, 2. Since my vertex is 1, 2, that means my graph might look something like this. I'm going to go ahead and draw it over here for you. My vertex is at the point where x is 1 and y is 2, so up 2. And we just need to decide, does my graph face up or down? And that will tell us, should our y values be greater than that point or less than that point? We're looking at your leading coefficient. My leading coefficient is a +3. That tells us our graph is going to be facing upwards. I don't really care much more than this. There are certain patterns you can follow, but all I care about is, does it face up or down? So my range starts at a y value of 2 and goes up from there. So my range are y values that are greater than or equal to 2. Go ahead and take a second and try these 3 on your own. Again, if you end up needing more time, just feel free to pause the video and take as much time as you need. For the first one, I found my vertex and then determined that it faces up because my leading coefficient is +2. So my domain is all real numbers, and my y values are greater than or equal to -1. For number 2, I found my vertex and found that my graph faces up because my leading coefficient is positive. Domain is all reals. Y has to be greater than or equal to -9. For the last one, I found my vertex, and since my leading coefficient is -5, my graph faces down, so my domain is all real numbers, and my y values for my range are less than or equal to -17. The last thing I'm going to very briefly touch on are maximum and minimum values. A maximum of your graph is when your vertex is the highest point and your graph faces down. Minimum is when your vertex is the lowest point, so your graph must face upwards. When you are asked to find the max or min, what we're looking for are the y values of your vertex. We'll talk about this a little bit more tomorrow. Thanks for watching. I hope you guys have a good rest of your day.